All right, today we're doing sum and difference formulas for cosine. So, sum and difference formulas. The cosine of A plus B equals the cosine of A, cosine of B, minus sine of A, sine of B. And the cosine of A minus B is the cosine of A, cosine of B, plus the sine of A, sine of B. Okay? Then, even though we're not covering it today, we'll put down the sine and the tangent ones. So the sine of A plus B is the sine of A, cosine of B, plus cosine of A, sine of B. And the sine of A minus B is the sine of A, cosine of B, minus cosine of A, sine of B. Are tangents. Tangent of A plus B equals the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. And finally, the last sum and difference, the tangent of A minus B, is the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. Get out your unit circles, please, because you'll need them today. Okay, so before we get into the sum and difference formulas, we got to work on finding sums and differences. Now, if we have 165 degrees, is the 165-degree angle on your unit circle? No, it is not. Shoot. How do we get 165 degrees out of two angles on your unit circle that are on your unit circle? What two angles add up to 165 on your unit circle? 135 and 30. Another one would be 120 and 45. Okay, so those are a couple examples. When you use degrees, it's super simple. You can add numbers really easily. Okay, when we work with radians, not so simple, such as 5 pi over 12. What equals 5 pi over 12? That's a little difficult, isn't it? So what we do is we start thinking, okay, is 1 pi over 12 on your unit circle? No. Is 2 pi over 12 on your unit circle? It is, just in another format. So if you think 2 pi over 12 plus 3 pi over 12 makes 5 pi over 12, correct? 2 pi over 12 is really pi over 6, right? And 3 pi over 12 is really pi over 4. So pi over 6 plus pi over 4 really makes 5 pi over 12. Okay? Makes 5 pi over 12. All right, so let's practice adding and subtracting here a second. What's pi over 3 plus pi over 6? Is it pi over 9? No. To add fractions, you need a common denominator. So 6 would be our common denominator. So pi over 3 is the same as 2 pi over 6 plus 1 pi over 6 is 3 pi over 6, which reduces down to pi over 2. Okay? Do another one. What's pi over 4 plus pi over 6? Well, yeah, I guess it is. You're a little smarty pants. All right, the common denominator would be 12. So you multiply the first one by 3, so it's 3 pi over 12. The second one by 2, 2 pi over 12. So then you get 5 pi over 12. Okay, let's do a subtraction one. What's pi over 2 minus pi over 6? What's common denominator? 6 would be. So if 6 is our common denominator, 1/2 is the same as 3/6. So it's 3 pi over 6 minus 1 pi over 6, which is 2 pi over 6, which is pi over 3. Okay, we good with adding and subtracting? Okay. So, what would you do to find 11 pi over 12? What would you do to find 11 pi over 12? Now, you need to know that you can't use 1 pi over 12 because that's not a unit circle. If you use 2 pi over 12, 2 plus what makes 11? Is 9 over 12 reducible? Yep. Is 2 over 12 reducible? Yep. So if they're both reducible, you can probably use them. So it's 2 pi over 12 plus 9 pi over 12. Or pi over 6 plus 3 pi over 4. Now, is that the only two we could use? No, we could use 3 pi over 12 and 8 pi over 12. We could use, we can't use 4 and 7 because 7's not reducible. We can't use 5 and 6 because 5's not reducible. So, yeah, those would be the only two options we could use. Well, not the only two, because we could use subtraction too if I really wanted to. But I don't think we're going to go there right now. Okay? All right. So now let's find the actual sum and difference of a couple of these. We'll work with degrees first because their degrees are easier. The cosine of 75 degrees. On your unit circle, what's the cosine of 75 degrees? Not on there, is it? There's no 75-degree angle on there. So that's why we have to use sum and difference formulas to find it. Cosine of 75 is the same as the cosine of 30 plus 45. This is A, this is B. Remember our formula. The cosine of A plus B equals the cosine of A, cosine of B, minus sine of A, sine of B. So we just fill in the numbers. The cosine of 30, cosine of 45, minus sine of 30, sine of 45. Now, what's the cosine of 30? On your unit circle. Square root of 3 over 2. What's cosine of 45? Square root of 2 over 2. Sine of 30. 1/2. Sine of 45. So this is the square root of 6 over 4 minus the square root of 2 over 4. We combine them into one fraction as the square root of 6 minus the square root of 2 all over 4. The cosine of negative 15 degrees. How do I get a negative 15? Let's work with smaller numbers than that. Cosine of 30 minus what? 30 minus what is negative 15? 45. Just the numbers we used in the last problem, except for it's a subtraction problem now. So it's the cosine of 30, cosine of 45, plus, because when this is a minus, this is a plus, sine of 30, sine of 45. Cosine of 30, square root of 3 over 2, cosine of 45, square root of 2 over 2, plus sine of 30, 1/2, sine of 40, square root of 2 over 2. So instead of being the square root of 6 over 4 minus the square root of 2 over 4. It's the square root of 6 over 4, or the square root of 6 plus the square root of 2 over 4. So instead of a minus, it's a plus. Now, all your answers today, when you get to the end, are going to look like this, because all of our denominators are going to be 12, or an angle that would be something over 12. Okay? Let's do another one. The cosine of 17 pi over 12. Oh my goodness. What two numbers add up to be 17 pi over 12? What over 12 plus what over 12 makes 17 pi over 12? And don't say 10 and 7, because 7 pi over 12 doesn't reduce. You need something that reduces. So you can't say 1 and 16. Can you say 2 and 15? 8 and 9 work. 2 and 15 work. 3 and 14 work. All those work. Okay. Let's just use 8 pi and 9 pi, since Miss Havlick wants to use 8 pi and 9 pi. What's 8 pi over 12 the same as? 8 over 12 reduces to what? 3/4, 2/3, what? 2 pi over 3. What's 9 over 12? So it's 3 pi over 4. So we're taking the cosine of 2 pi over 3, cosine of 3 pi over 4. If this is a plus, then the sign is a minus. Sine of 2 pi over 3, cosine of 3 pi over 4. All right. So, what's cosine 2 pi over 3 on your unit circle? Negative 1/2. Cosine of 3 pi over 4? Negative square root of 2 over 2. Minus sine of 2 pi over 3? Square root of 3 over 2. Cosine, well, it shouldn't be cosine, should be a sine there. Mr. Bierschbach, don't boil your students up like that. Sine. What's the sine of 3 pi over 4? Square root of 2 over 2. Yeah, for surely. So you get the square root of 2 over 4 minus the square root of 6 over 4, which is the square root of 2 minus the square root of 6 all over 4. All right. Are we good enough, or do you want one more? Okay, so what are your problems going to look like? Well, you're going to do some adding and subtracting of fractions like this. Okay? Then you'll be given just numbers, and you'll have to figure out what adds to be that number. Then you'll do sum and difference formulas. So on page 179, you have numbers 3 through 29, the odds to do. So you don't have to do sum and difference formulas, the whole formula, until you get to number 19. Otherwise, you're just figuring out what fractions add up and subtract to be that. Okay? But starting with number 19, then you have to do the sum and difference formula. All right. Just one lesson today, because too many people are gone and some more people are leaving. So, there we go.